Hello everyone, welcome to the follow-up tutorial. Today we'll try to make this figure. This is a figure where I highlighted actually how a zeolite LTL looks like. So what you can see are the three structural building blocks that we're using. So in the gray it's a sodalite cage. It's a small cage in which you can't really absorb. Then you have um, a double four-ring, which is in green. And you have this in transparent, this alpha cage of the LTR. So it's an alpha or a super cage where the absorption takes place. And this is what we're going to visualize. So I will start from scratch and showcase how you do this. Okay, first things first. I downloaded the zip file from the International Zeolites database. So this is the thing you would see if you would load it in. And we're going to start from that. So if we look to our original figure, you see that there are no oxygen atoms available or shown. We connected the T atoms, so this is the silicium or the aluminum, together. So that's what we're going to do over here as our first step as well. There are multiple ways of doing this. You could go to edit data and you could just straight up remove the oxygen atoms out of your work. This is this disadvantage that at a later stage, if you did want to show them, you have to re-add them or remake your figure. So personally, I don't like to use them. There is a much more simple way. You can just turn off their visibility and the bonds. Now the bonds, it doesn't really matter. I'll keep them on. Why? Because we're gonna change the bonds later on. One thing I do want to change before we start is maybe add a bit more of their boundaries. So if I add more boundaries, boom, there you go. You can see we get multiple cages next to each other. Okay, so this makes it a bit easier. You'll see later on why, because we really want to identify the structural units by each other. So I'm going to change the bonds now. For that, I can press Ctrl B, or you can go to bonds over here in Edit. If you go to bonds, right now we have a silicium oxygen bond. To be honest, I don't want them to be connected anymore. So I will put them to search for silicium. Do not search outside of the boundary as well, and then their length. Typically, I know from experience, it's about 4 angstrom. That's sufficient, and they will be all connected. You see the oxygen bonds are also removed because we removed them, and you get them. Now, if you're not sure about what the length is between atoms, you can also just do it by trial and error. For example, if you do 3, it's not sufficient. It's 3.5. It is sufficient, or 4, it's also sufficient. Don't go too long, because if you go too long, obviously silicium atoms will maybe go too far, and I think I can show this as well. You will start to get these kind of structures where they will go further connected than what you would expect. So about 4, I think that's fine. Okay, so with that, you can already see a bit of the structure better. We can see like this, maybe. We can see the large spherical cage, which is the one here in blue. Then in the middle here, this the smaller units. It is a bit more difficult to see. It will be the gray unit actually, like the Zeolite cage, and then you have double four rings or cubuses, where you can see them over here actually, but then it's obviously in 2D. But it's a bit difficult to see, I must admit. And what we want to do is we want to make surfaces around them, and for this, what we do is here we do a trick. We use a polyhedral structure. If we would just add it here, it doesn't work. Why? Because the polyhedral, he just checks for where he can form a polyhedral, but there are only silica atoms. So what we will do is, I'll reset this. What we will do is we'll put an atom actually in the places where we want to create these structures. So we'll add fake atoms, and this way we'll create polyhedral structures around the structures that we want. So it's an artificially made polyhedral. But this works very nicely, as you can create nice figures with it. So the first thing we want to do is add, so we go to structural parameters over here, where you get all your atoms. And what we're going to add is, we're going to add a fake atom. You'll see in a second why. You can choose a symbol. To be fair, it doesn't really matter which one you add. And let's start off with the big cage, maybe. That's maybe the best thing, the big cage. So it's, I usually write fake before it, so I know it's a fake atom, and then alpha, because we're going to put it in the alpha cage. Now, if you would just apply it, you would see the atoms are placed according to the symmetry. So here you see in gray all the nickel atoms, which they're fake atoms. They're not actually in the structure there, but we have just added them. They're placed, but they're not really in the center of this large spherical cage that we have. Now you can do this by trial and error and try to find out really what you need. Of course, I'm prepared and I know exactly where they are. So if I put zero point 0.5, that's not the case. They are actually in the center of the double flooring, which we'll use later on. But I know from experience that 0.5, 0.5, 0.5. And then you see they're nicely in the middle. Now, it's easy for me because I know them already. How can you find them? Look to your symmetry. This is a very simple model or symmetry, so it's quite easy to find them. But you can also do it by trial and error. Really, they need to be somewhere in the middle of the structure you want. And thus you can just add values and see how they move, and then think about it, how you should move them. For now, it's fine. They're in the middle. And that's quite okay. So I can just press OK, and it looks fine. They're in the middle. Now, if I would press Polyhedral, it still doesn't work. And this is because we need to connect them with silicium atoms. For this, we go again to the bonds menu. I press Ctrl B again. So I make a new bond. And I want it to connect the nickel, which is the fake atom, to our silicium atom. I don't really want him to search outside of any boundaries, so I'll put that off, sure. If I would apply it, of course, it doesn't work because the max length is too low. Here again, it's a bit by trial and error finding it out. You have 5, nope. 6 doesn't work, nope. This is because it's a large spherical cage. It's about 8. And now you can see it's a lot of bonds that over there. But what happens is this molecule in the middle is connected to all the other molecules on the side. And you get this is what we want actually. So all these bonds, but they are again artificial bonds. We don't really want them because they're not in the real structure. But it helps us with our polyhedral view. Because if we would now turn on polyhedral, boom, we get already quite what we want. And that's obviously interesting because this is, you see the spherical cages are well shown now. What we can do is, because it's still a bit ugly, yeah, we must admit that, you have all these bonds which are not in real life there. Two things you can do. You can just turn off these bonds. Sometimes it bugs out, it says it's not on, but it is on, and so on. You can also turn off these atoms, and it's just cages. And you can also play around with the colors, of course. So you can choose colors. I will choose blue because that's how I did in the previous figure. And you can play around here if you click to the right side here with the transparency as well. How transparent you want it or not. Like this. I think that's already looking quite nice. Okay. Now, we haven't got this yet. We have only the spherical cage in blue, but the Zeolite cages and the double floor rings, they're not added there. So we just repeat this process. For this, it's a bit easier if you stick to the ball and stick model. And we'll go again to our data. And now we'll add another fake atom. So this was fake alpha. I think I press enter. See, I'm still a noob. Like this. Here you go. So fake alpha. Now I want to make a new atom. Maybe with a different atom is the best thing to do because you don't want the bond rules to overlap. And now let's do the fake Zeolite. There you go. Fake Zeolite. And for this, I want to just be at 0.0.0. And what will happen is the copper is maybe not the best example. Let's try aluminium. There you go. This is a different color than the silicium. And then you can see they're placed over here. It's a bit difficult to see, but trust me, these blue ones are actually in the middle of the Zeolite cage. It's a bit difficult to have because we have all the bonds already in there. The bonds, they re-show as soon as you change some data. So even if I turn it off in the object menu over here on the left, you see it shouldn't be shown, but yet it is. You can turn it off again. This is a bit of the bugginess with the VESTA that you will encounter. But you can see this parameters is in the middle of our Zeolite cage. And that's fine. And if you don't see it yet, don't worry. Let me see. Yes. Like this, that's perfect. The atoms are not showing for some reason. like this. Yes, you see it. Sometimes it's a bit buggy, but don't worry, you'll get there. Again, we open the bonds menu because now what we want to do is create bonds between the silicium atoms and this fake atom, aluminium atom that we added, like so. Obviously, we want them to have again the nice bond length, so it's about 4, I think. And here it is important to think about the boundary mode. If we would put it on do not search beyond the boundary and we apply it, so bond length is not sufficient. I think it's like 5 or 6. 5. There you go, 5. So now you see all these fake aluminium atoms are connected to our silicium rings. And this works, but the problem with this is if we would now put on the polyhedral structure, it would also only form in the middle over here. The sides, they're not included. And this is because how we define our bonds. We can change it to search additional atoms if A1, so that means aluminum, is included in the boundary. And that's what we actually want, because we want to form a nice round structure on it. Because if you see, if you apply it, you get these nice cages as well. And this is what we want. So I press OK. And now it already looks a bit better. They are the same color, so it's a bit difficult to see. But what we can do is the fake Zeolite, change our color to, for example, gray. And there you go, you get the same. And now the last thing that's there to do is to add a fake atom in the middle of the double four ring, connect it to the silicium atoms, and again, create a polyhedral. So without further ado, let's add it. Let's take phosphor or something. It doesn't matter, like I said, which atom you change. You can change all the colors and properties later on if you want to. So this is the fake double four ring. There you go. It's placed at, I do have to specify where it's placed at. It's placed at 0.5, I believe. Yeah, 0.5. There you go. And I can see the phosphors are nicely in this double four. Press OK. We open up our bond menu again, create a new bond between the phosphor and the silicium. The boundary mode, I do not really want them to go outside of the boundaries. It doesn't matter in this case, but always think about if you want it or not. I think it's about 3 or 4 angstrom as well. It's 3 is even sufficient, I think. Yeah, we'll leave it at 4, it doesn't really matter. And there you go. Now our figure looks, well, the structure, it looks really awful, but all our components or our building blocks are highlighted. And now you're through the most difficult parts. The only thing now is to make it more pretty. So I'll quickly show you what I would do. I would turn off all these atoms for starters. Also the bonds, you see they're deselected, but due to the bugginess of VESTA, it does show them. Double click them again and you get them like this. Then in the polyhedral, we can still change stuff as well. I will change these to the green ones. And what I also would like to change is that the transparency is different. So for example, here the transparency, I don't want it to be transparent at all because there's no adsorption taking place here with large molecules. So let's just turn it off. Similarly here, and the color, we put it to gray like this, like so. And that the blue is transparent, I don't really mind too much, to be fair. The last thing we want to fix is really these atoms and so forth. We can turn them off. Now we're already quite similar to what we have over here, but we still have blue bonds. Then you go to style and then to properties. Yes, and then you can change the bonds. You can use a cylinder, a colored line. I believe it was a unicolor cylinder, I guess. And there we go. We have the figure. The figure looks quite similar already, but we have here a lot of cages and actually only want one to show. So we go to our boundaries and we will change it to 1. Now you can see you get 1 cage, but the bonds again are reset. This is a bug, so you will have to change it again. It's this one. Yes, it's this one. And there you go. You have this nice figure. Let's put it a bit better like this. And you have the figure. It's very similar to the one over here. Why did I start off with our boundary in the beginning at 222, that's because then you have more cages, and for me it's a bit more easier to visualize where the structures are. But of course, you could have done it pure by doing so, by working with these boundaries. It really depends on if you have knowledge about the framework or not. So usually I like to increase it a bit in the beginning. But there you go. You have the figure. You can now save this figure. This is just saving a lot when you're using VESTA. You can save this VESTA in a VESTA format. And then it will really save how it looks right now. You don't have to reset anything. And if you want to have a picture, you can export it as a raster image. You have a bunch of options of how you want to save it. I usually save it as a TIFF file. Let's do it in downloads. I will replace it. And then it will ask you what the scale is. Do not put it very high because it scales the X pixels you have in your current monitor. For example, if you have 1,000 pixels and you put 3, then you get 3,000 pixels width. So if you put like 10 or 20, what will happen is your memory of your PC will be too small to generate these pictures. So be very gentle with these pictures. Usually, if 2 or 3 times the scale is more than sufficient. For in addition, the background transparent, it doesn't really work, so I don't check it. So I use scale 3, and if I now press OK, it will generate a picture. Give it a second. There you go. And you have to believe me on this, but the file is already close to 60 megabytes, and you get this file. And now, if you're happy with the figure, you can use it. You can crop it a bit so axis doesn't show and so forth. You can still also change the angle if you want to, or change the field of depth. Again, that's with overall appearances, where you can change the depth if you don't want this transparency to happen for depth. I like it, so I usually leave it on, but you can change it around. But this is how you make the figures. And to reiterate what were the important things, you add fake atoms so you can make these polyhedral structures. Maybe a last trick. Let's say if we had a boundary of, let's make it 2, so you get 2 cages, and again you have this small block which we'll fix. Let's say you want to remove just one of these. What you can do is, if you go over to select or press S, you can select individual parts of the framework. Again, this is a bit buggy, just like with the distance. Sometimes it doesn't select the right thing, or it selects multiple similar polyhedrals. But now it just did one, so it's very nice. For the you can see, you can delete it like so, and then you just have only this one. So you can really delete single elements. Now this will reset if you, for example, change your boundary again. If you would go back to 1, it would be gone. So be a bit careful with it. Do this at the very end if you want to really remove specific things. But this is a more hackerish way to get or delete stuff that you want. But it is possible. Ideally, you don't have to go through it because it can be quite cumbersome. But yeah. So we get this figure. If you have any questions, please let me know. And already thank you for listening.